Welcome viewers. In this video, we'll see the capacitance, definition, derivation and the problems. First we'll see the capacitance. You know that capacitance is nothing but it is formed using two conducting media with an insulator in between them. So the capacitor is a storage element. It is nothing but there are two conducting mediums are available. In between, insulating material will be presented. So the two conducting media with an insulator is called as a capacitor, right? First we will see the capacitance of parallel plate capacitor. There are various types of capacitors available. First we will see what is the expression for capacitance in case of parallel plate capacitor. So this parallel plate capacitor is shown in the diagram. So this is the two plates are available. Plate 1 and plate 2 parallelly it is placed. The dielectric is available in between the parallel plate. So the V is the applied voltage between the parallel plate and the distance between these two plates is d meters. Right? The parallel plate is available, applied voltage is V, the distance between the plate is d. Here the dielectric materials are available. So first we will see the derivation. So based on the Gauss law, the electric field intensity is given as E equal to Q divided by A epsilon. That is Q divided by 4 pi epsilon r square. That 4 pi r square is taken as A, so that it is Q divided by A epsilon. You take this equation number 1. And also in general, the electric field intensity is given as V divided by D, potential divided by distance. Right? So take this equation number 2. Right? From equation 1 and 2, so both are same. Equation 1 and 2 both are electric field intensity, so that we can equate this side. This side can be verified because both expression is for the electric field intensity. So from equation 1 and 2, so V by D equal to Q by A epsilon. Right? From equation 1 it is Q by A epsilon, equation 2 V by D. So both are equated. Now we substitute that Q equal to CV. You know that the general formula Q equal to CV. So that V by D equal to CV divided by A epsilon. Right. So this V got cancelled. Right. Bring this term in the numerator. Right. So that A epsilon by D equal to C. So that can be written as C equal to A epsilon by D. That is a very general formula. C equal to A epsilon by D. Right. So that is. So from the above expression, this capacitance is directly proportional to the area of the plate and inversely proportional to the distance between the conductors. Right? So what is the meaning? If you increase the area of the plate, the capacitance will increase. Similarly, if you decrease the distance between the plate, the capacitance will increase. Right? So it is A epsilon by D, the general formula. Now we'll see the capacitance of parallel plate capacitor, two media, that is two conducting media, two dielectrics. Right? Previously what we discussed is only one dielectric. Right? So refer this diagram. So this is the parallel plate. Two plates are available. In between the dielectric material is filled, but the only the portion of the dielectric is epsilon R1. First dielectric with epsilon R1. We have another dielectric with epsilon R2. Right? The two different dielectrics are available between this parallel plate. Epsilon R1. The dielectric, the permittivity of the first dielectric material is epsilon R1 and the second dielectric material is epsilon R2. The thickness is D1. This will be D2. Right? The applied voltage is V. Total voltage applied across the parallel plate is V. That is the drop across the first dielectric material is V1. Second one will be V2. Right? So we have D1, D2. Voltage is V1, V2. The permittivity will be epsilon R1 and epsilon R2. Right? So we'll go to the derivation. So the applied voltage V equal to V1 plus V2. Right? Voltage across the first dielectric material plus voltage across the second dielectric material. Right? So that is equal to V equal to, we know that E equal to V by D. From that V can be written as E into D. Right? So that E1 D1 plus E2 D2. Based on the formula, we know that E equal to V by D, so that from that we can write V equal to E into D, right? Now this E can be replaced as Q divided by A epsilon. The general formula for electric field intensity is Q divided by A epsilon 1. Due to E1, it is Q divided by A epsilon 1 into D1. This E2 is replaced as Q divided by A epsilon 2 into D2. Right? So the Q by A is commonly available in both the terms. So that is taken outside. So that what we have, D1 divided by epsilon 1 plus D2 divided by epsilon 2, right? Q by A is taken outside. Now we'll substitute Q equal to CV, right? The charge, the Q equal to CV, we will substitute here, we will replace this Q equal to CV, so that this V got cancelled, right? Now we bring this term in the numerator and bring this term in the denominator, so that A equal to C equal to A divided by D1 divided by epsilon 1 plus D2 divided by epsilon 2, right? So now we got the expression for capacitance. Now this epsilon 1 is nothing but epsilon 1 can be written as epsilon naught into epsilon r1. Similarly, epsilon 2 is epsilon naught into epsilon r2. That is absolute permittivity and relative permittivity. So this absolute permittivity is a common. This relative permittivity depends upon the material. First dielectric, and this one will be second dielectric, right? So this epsilon naught can be taken common. This epsilon naught is available in both the terms. So 1 divided by epsilon naught, it will go into the numerator. So that A epsilon naught divided by D1 divided by epsilon r1 plus D2 divided by epsilon r2, right? So this is the expression for capacitance with two different dielectric material. Now we'll see the problem based on this capacitor with two dielectric material, right? We'll see the statement. A parallel plate capacitor consists of two square metal plates of side 500 mm, right? The area of the parallel plate is 500 mm. The side, the one side is 500 mm and is separated by 10 millimeter, right? The distance between the two plate is 10 millimeter. In this, the Teflon is available with epsilon r equal to 2 for a thickness of 6 millimeter. Out of 10 millimeter, 6 millimeter is available with a Teflon, the dielectric material called Teflon, with epsilon r equal to 2, and is placed on the lower plate having a air gap of 4 millimeter. So the remaining 4 millimeter will be air gap. So total 10 millimeter. Out of 10 millimeter, 6 millimeter is Teflon with epsilon r equal to 2. Remaining 4 millimeter will be air gap, right? The voltage applied is 100 voltage. 100 voltage is applied. We need to find capacitance, displacement density, electric field intensity, and voltage in both Teflon as well as air. We need to find all these parameters for Teflon as well as air, right? Now we'll see the given data. What are the data given? So the area, the side is given 500 millimeter. So the area will be 500 into 500 millimeter square, right? Side into side. So millimeter square is converted into meter square. It is multiplied by 10 to the power minus 6. So 500 into 500 into 10 to the power minus 6 meter square, right? The distance D1, thickness of the first dielectric is 6 millimeter, that is 6 into 10 to the power minus 3 meter. The thickness of the second dielectric, that is air, is 4 millimeter, that is equal to 4 into 10 to the power minus 3 meter, right? So the epsilon r1 is given as 2 for the Teflon. The epsilon r1 value is given as 2. The epsilon r2 will be 1, that is air gap. For air gap, the value will be 1, right? The applied voltage is 100 voltage. Then epsilon naught, absolute permittivity, is 8.854 into 10 to the power minus 12. That we know that is a constant. So by using this, we will find the values one by one. First we will find the capacitance. So the capacitance with two dielectric is nothing but epsilon naught A divided by d1 divided by epsilon r1 plus d2 divided by epsilon r2, right? Now we'll substitute this value. Epsilon naught is 8.854 into 10 to the power minus 12, right? What is the area? 500 into 500 into 10 to the power minus 6, right? So this is first dielectric, right? First dielectric, the thickness is 6 into 10 to the power minus 3. The permittivity value is 2. Second dielectric, 4 millimeter, 4 into 10 to the power minus 3, that is air, so that the value will be 1, right? So by simplifying this, what we got? 3.16 into 10 to the power minus 10 farad, right? So first we calculated the value, capacitance value is calculated for this two dielectric material. C will be 3.16 into 10 to the power minus 10 farad. Now we need to find the remaining values: displacement density, electric field and potential. So before that, value of charge density in plate 1 and 2 is same, since the charge and area of the plate 1 and 2 are same, right? That means the displacement density will be equal for both the cases, because the charge density in plate 1 and 2 are equal, so that the area of the plate 1 and 2 also equal. Now we'll find the remaining value. Capacitance value is calculated. Now we'll see the displacement density. That is nothing but Q divided by A. Displacement density is nothing but Q divided by A. So that is Q is replaced by CV divided by A. Q equal to CV divided by A, right? The displacement density is nothing but displacement per unit area. So based on that, Q by A, Q is replaced by CV divided by A. Now we'll substitute this value, C. Now we calculated this C value, capacitance 3.16 into 10 to the power minus 10. The applied voltage will be 100. What is the area? 500 into 500, 10 to the power minus 6, right? We will substitute all the value. So it is better to take 5 to 6 decimal, so that the answer will be very accurate. Normally, if you take the 6 digit after the decimal, the answer will be very nearer, right? So 0.001264 into 10 to the power minus 4 Coulomb per meter square, right? This displacement density, right? We are taking 6 decimal and also 10 to the power minus 4 also available, right? So from this D value we can find E1 and E2. So E1 equal to D1 divided by epsilon naught into epsilon R1. We know the relation between D and E, right? So D equal to epsilon E. From that, E equal to D by epsilon, right? So the D1, D2 is there, both are equal. D1, D2 are equal to D. So D value is 0.001264 into 10 to the power minus 4. Thus we calculated, divided by epsilon naught, that is constant, 8.854 into 10 to the power minus 12. Epsilon R1 value is 2, right? So by simplifying, what we got? 7138.02 voltage per meter. Nearly it is 7000. 7138.02 voltage per meter. Similarly, we can find the E2 value. E2 equal to D2 divided by epsilon naught into epsilon R2. So the D2 also same. 0.001264 into 10 to the power minus 4. That is available here. Divided by epsilon naught is constant, 8.854 into 10 to the power minus 12. Epsilon R2 is 1 because of air medium. So by simplifying this, what we got? 14,276.03 voltage per meter, right? So now we got the value of V1 and E2. From that we can find V1 and V2. So V1 equal to E1 into D1, that is E equal to V divided by D. From that, V equal to E into D. So the E1 value we calculated. E1 value is 7138.02 into the D1, the distance. The first dielectric will be 6 into 10 to the power minus 3, 6 millimeter. So what we got? 42.83 voltage. Similarly, V2, E2 into D2. So E2 we calculated 14,276.3 voltage per meter into D2. D2 is the air gap, 4 millimeter. 4 into 10 to the power minus 3. So by simplifying this, what we got? 57.10. So V1 will be 42.83, V2 will be 57.10. So by adding these two, what we got? 99.93 voltage. That is the applied voltage is 100. We know that applied voltage. So by adding, it is nearly we got 99.93. So the value what we got calculated is almost correct. It is nearer to the 100 voltage. That's why we are taking the displacement density as a 5 to 6 digits, right? So now we calculated capacitance, then displacement density E1, E2, V1 and V2. So all values are calculated. Now we'll go to the one more problem. So in the second problem, the capacitance value is given, that is 2 into 10 to the power minus 10 farad. The capacitance of a condenser formed by two parallel plates. The area is 100 centimeter square and separated by 2 millimeter. For this, the value will be 2 into 10 to the power minus 10 farad. Right? So the area of the plate is available, the thickness, the distance between the plate is available, and the capacitor value is available. The potential applied is 20 kilovolt, 20 kV. Right? We need to find the value of charge, electric field intensity and relative permittivity. We need to find these three values, right? First we will see the given data. So the area is given 100 centimeter square. While converting into meter square, we need to multiply 10 to the power minus 4. So the area is 100 centimeter square, that is equal to 100 into 10 to the power minus 4 meter square. The applied voltage is 20 kV. 20 kV means 20 into 10 to the power 3 voltage. Kilo voltage means we need to multiply with 10 to the power 3. The distance between the plate is 2 millimeter. That is equal to 2 into 10 to the power minus 3 meter. Millimeter to meter means we need to multiply with 10 to the power minus 3. The capacitance value also given, C equal to 2 into 10 to the power minus 10 farad. Right, so these are all the given data. From that we can find the values one by one. First we will find the charge. Charge Q equal to CV, very standard formula. Q equal to CV. So that C value is given 2 into 10 to the power minus 10. The voltage is 20 kilovolt, 20 into 10 to the power 3. So multiplying these two, what we got? 40 into 10 to the power minus 7 Coulomb. The charge will be 40 into 10 to the power minus 7 Coulomb. Then we will find the electric field intensity, E equal to V by D. These two values are available, voltage available, distance available, so that we can use this formula, right? V by D. So V equal to 20 kilovolt, 20 into 10 to the power 3 divided by the distance is nothing but 2 millimeter. 2 into 10 to the power minus 3, that is equal to 10 into 10 to the power 6 voltage per meter. Right? The electric field intensity will be 10 into 10 to the power 6 voltage per meter. Now we need to find one more value, that is permittivity, relative permittivity. That is from this formula we can find C equal to epsilon naught epsilon R A divided by D. It's a very standard formula. In this C is available, epsilon naught is available, area available and distance also available. Right? So cross multiply and simplify this expression so that epsilon R equal to C into D divided by A into epsilon naught. Right? So because we need to find epsilon R, so it is rearranged such a way that epsilon R equal to C into D divided by A epsilon naught. Now substitute the C value. C is 2 into 10 to the power minus 10. The distance is 2 millimeter. 2 into 10 to the power minus 3. The area is 100 into 10 to the power minus 4 meter square. Then epsilon naught value is 8.854 into 10 to the power minus 12. Now all the values are substituted. By simplifying, what we got? 4.517. Right? So in this problem we calculated the charge value, electric field intensity and the capacitance. From this capacitance we calculated relative permittivity. Right? So in this video we discuss about the capacitance definition, derivation and two problems.